Hi, I'm Carly McAvoy doing the final exam review today. We're doing chapter 6, which has several questions, not a ton, but each one of these takes a while. So for some people, for one thing, we're going to be factoring to simplify. So this is a rational expression. Rational expression just means it has fractions. To simplify this, we need to factor the top and we need to factor the bottom. When you factor the top, you're going to break that up into two groups. There's a minus in front, so I want to make sure and keep that separate. Minus 2x minus 14. And then down below, I'm going to factor that. And I can factor that on the bottom just by looking at it, because what I have is two numbers that multiply to 7 but add to 8. Well, not a lot of options there, because we know that 7's a prime number, and so it has to be 1 and 7 there. But I haven't finished factoring the top, so let's keep going on that. Up here I have a common factor of x squared, and that gives me x plus 7. And then I have a common factor of -2, and that gives me x plus 7. And here's where people tend to make a mistake, is they want to cancel right here. You can't cancel when things are still being added and subtracted. It have to be multiplied. So we need to finish this. We have a common factor of x plus 7. Like a common last name, we can take that out. If we take out the x plus 7 on the top, what's left is x squared minus 2. And so now we can cancel, because now we have two binomials that are being multiplied. When I cancel this and that, this is my final answer, x squared minus 2 over x plus 1. And that's it. Okay, next one. This is a complicated thing that people make a lot of mistakes. It's just easy to make a mistake on this subtraction problem. In order to subtract, I first need to find the least common denominator. So I need to write this with these things in factored form. Two things that multiply to 14 but would add to 5 would be 7 and 2. We wouldn't get the signs right on that, but I know I'm going to have 7 and 2. Which one needs to be positive? Well, I need more positive, so it's going to be positive 7, negative 2. And over here, two things that multiply to 35 but add to 2 could be 7 and 5. So let's see, we have x and 7 again, and then x and 5. We need more positives, so again, we need more 7 positives, 5 negatives. That's our least common denominator maker then. We can see what it has to be. The LCD has to represent all the fractions, so we need an x plus 7 and an x minus 2. Then move on to the second one. In the second one, we need an x plus 7, but we already have that, and an x minus 5, which we don't have yet. So our LCD is that. So now what we want to do is multiply both terms by x plus 7, x minus 2, x minus 5. And I write it out both times so I don't forget and mark something off that shouldn't have been. So what happens here, when I multiply these two things, the x plus 7's cancel, the x minus 2's cancel, and what I have left is x plus 5 times x minus 5. This whole thing is going to go over our LCD, which I don't want to write every time, so I'm just going to remind myself that it's down there. Then I have minus, and what happens is x plus 7 and x minus 5 goes, so I have 2x plus 1 and x minus 2. I have to multiply the top by what's missing from the denominator, essentially. So then I'm going to multiply this stuff out. I get x squared, the minus 5x and plus 5x goes away, minus 25. Be careful here because we have a minus in front of this. We have to distribute that minus. So we're going to have to first multiply this out. 2x squared and minus 4 plus 1 is minus 3x minus 2. And now I'm going to distribute that and get x squared minus 25 minus 2x squared plus 3x plus 2, whole thing over LCD. X squared minus 2x squared is negative x squared plus 3x, and negative 25 and plus 2 is negative 23. That cannot be factored, don't worry about it. And your LCD then is back in for the final answer, x plus 7, x minus 2, x minus 5. That's it. Just be careful about distributing that negative. That's the most common mistake. The steps are find the LCD, multiply both fractions by the LCD, and then simplify the numerator and put the whole thing over the LCD. You don't get to get rid of the common denominator here because you don't have an equal sign. You can't get rid of it. Okay, next we have a simplify a complex fraction. And the steps for that are going to be to find the least common denominator and then multiply everything by it. This is like 1 over 1. So the LCD here, I have x's and then x squareds. So the least common denominator is x squared. So I'm going to multiply everything times x squared. And what happens is those x's cancel out. I get 1. This x cancels one of those x's, leaving 4x, x squared times 1. And then x cancels one of those, leaving 1x. That's your answer. You could go a little further and do 1 minus 4x and x times x minus 1, but it doesn't help any, right? Because we can't cancel anything in this problem. What if you came down to something like this? Well, then you would want to finish factoring out that x because this would allow you to cancel. But what if you just have an x in the denominator? Remember, it's a 1 on the top, right? I think this is kind of what happens on your finals. You do get to cancel and you have that last variable left. You want to make sure you put it in the denominator and not the numerator. This is the end of that problem. This was just a little what if over here. What if you could simplify? Okay, and finally, solve this equation. And remember, when you solve a radical equation, there's a potential to get a restriction or something that you can't use. What would be the restriction in this problem? Well, x could not be 0, because if it was 0, we'd have something that's undefined. And the other one is x cannot be negative 1/2, because also if you had negative 1/2, 2 times negative 1/2 is negative 1, plus 1 is 0, and now it's a restriction. We can't do it. Similar to the problem above, we want to find the LCD and multiply everything by it, but different from above is that we are not stuck with that least common denominator. We're going to get rid of it because we have an equation. We can do that. Well, we need a standalone x, and we need the 2x plus 1. That's going to be our LCD. X and 2x plus 1. So when I multiply this, the 2x plus 1's go, and I get 2x. When I cancel the x's, I get 2x plus 1. And when I cancel the 2x plus 1's, I get negative 4x squared. Now I'm going to move everything to the other side. I always want my lead term, that's the highest power term, to be positive. So I'm going to shift that over by adding 4x to both sides, or 4x squared, sorry. I'm also going to subtract 2x from both sides. That's going to go away then. And I'm going to subtract 1 from both sides. And now whatever you get, if you get a trinomial, factor the trinomial. We have a difference of squares, so 4x is 2x and 2x. I always do that. I don't want to put the parentheses yet. And then 1 is 1 and 1 plus and 1 minus, plus and minus. Now I'm going to set those two things equal to 0. 2x minus 1 equals 0, and 2x plus 1 equals 0. This is going to be a problem because when I solve 2x plus 1 equals 0, I get x is negative 1/2. When I solve this, I get x is positive 1/2. Move the 1 over, divide by 2. Well, I already said when I started I can't let x be negative 1/2, so that's not a solution. And the only solution to this is x equals 1/2. Expect to see that on your final. You will have to eliminate one of those solutions as being extraneous, so try to remember that. Put that little bit of notes in your final. Okay, then the last one for number 6 is an application problem. And this one says Selena can complete the assignment in 3 hours while it takes Lynn 5 hours to do the same assignment. How long if they work together? Well, this is a typical work problem, and there's more than one way to do it. And so I know that some of the videos of the class done by a different instructor, and I don't know how she explains it. So if I explain it differently, I'm going to apologize in advance. But I'm going to say T equals the time together. 3 is time for Selena, and 5 is the time for Lynn. And I'm always asking, what can be accomplished in 1 hour? Okay, so Selena could do 1/3 of the job in an hour, and Lynn could do 1/5 the job in an hour, and the time together would be 1/t. So that's where I'm going to get my equation from those three things, because Selena and Lynn are going to work together. So we're going to add what they can do, and when they do, that's going to give us that combined of the what if they work together thing. So like the previous problem, we're going to find an LCD. 3 times 5 is 15, and we have t. So we're going to multiply everything times 15t. 3 goes into 15 5 times, so I have 5t. 5 goes into 15 3 times, so I have 3t. And the t's cancel over here, so I have 15. And then 3 and 5 is 8. And divide by 8. And time is 15/8. And if it asks for a fraction, you could divide that out and get that out. It's almost 2 hours, but not total. So those work problems, I think, are the easiest ones out of that, the type to put in that. So I don't think it's going to be that bad for you. And that's it for Chapter 6. Have a fantastic day.